Good day. In this final lecture for C programming, we go to chapter 9, arrays. 9.1, array definitions. For one-dimensional array, the array definition is storage class, data type, array name, and in square bracket, array size. By default, storage class is automatic. When defined outside the function, it's going to be external. So in normal case, you just neglect this. It's going to be automatic. Array size is a positive integer number, which indicates the number of elements inside the array. Example, here we have X is a one-dimensional integer array, size 100, so you can store a maximum of 100 elements. Next, text is a character array, you can store a maximum of 80 characters. Array definitions can include initial value assignment. For example, here, integer x 100 semicolon, there is no initial value. But here we have initial value. X integer array has 4 elements. Number 1, 2, 3, element number 4. Color is a character array, size 3. So color has 3 elements, as shown in as follows the following results. In general, for n element array, the subscripts will range from 0 to n minus 1, because in C, we start counting the subscript or index from 0. And any array elements not assigned specific initial values, the compiler will automatically give them zeros. For example, here, if I put integer x 4 semicolon, no initial values, so basically the computer will set all these to zeros. x0 to x3, they're all zeros. Array size need not be specified when initial values are included in the array definition. Here we have the size 4. Here there is no size because we have initial values. So the compiler knows there are 4 array elements, and the compiler will put 4 there. Second case here, without the size, the computer knows there are 3 array elements. So the size is going to be not 3 but 4, because character array at the end of the, basically here, combine the 3, you get a string constant. At the end of string constant, you have the /0, end of string marker. Consider these character array definitions. Color 3 elements. Here we give the, not using this convention, but we specify the initial value as a string constant. It has the same effect as this. Will also result in, this is going to be color 0, color 1 is E, capital E, color 2 is going to be capital D. So basically you get the same results as before. So for one-dimensional arrays, for numeric arrays, you have to assign the data in this way, within the curly brackets. And character arrays are not tested in test 2. They're not tested. 9.2 array processing. Array operations are basically carried out on element by element basis. First, look at one-dimensional array, and your test 2 is going to cover only one-dimensional array, such as this. So here we have 5 numbers, and we want to find the average of these 5 numbers. Let's write a simple program. Let's keep these numbers in a one-dimensional integer array named x. Has 5 elements, and these are the values: x0 to x4. In this loop, we use the not the number itself 10, but the address where we keep the actual values. So basically we are going to add xi. I is going to be from 0 to 4. We add xi to sum in this loop. Of course, initialize sum to 0. So at the end of the loop, basically, we have the cumulative sum. And then we divide by 5, of course, we get the average. Printf average, you run this program, you get this output. Of course, previously, by not using arrays, we would have solved this problem by, for example, 4, not using arrays, x equal 10, x less than or equal to 50, x equal to x plus 10. That is not using arrays. But here we are using arrays, so to get the values, we have to use the address of the array element. Two-dimensional array, this is not tested. Let's say we have 2 matrices, A and B, both are 3 by 2, 3 rows, 2 columns each. And we want to add these two and keep the results in C. We get a new matrix C. So general equation is going to be, so let's say I is the row index, J is going to be the column index. And for 2D arrays, of course, the first bracket is for row address, second bracket is for column address. So general equation is going to be Cij is equal to Aij plus Bij. So I is going to be 0, 1, 2. J is going to be 0, 1. Let's write a simple program to add A and B. So we declare A as integer array. It's no longer one-dimensional. The size is now 3 by 2, 3 rows, 2 columns. And these are the elements of the array, 2D array. First row, second row, third row of A. First row, second row, third row of B. B is also 3 by 2. We could have also written this, of course, in this way. But normally we write in this way because it saves a lot of space. This can also be written in this fashion. C is now also same size as A and B, 3 by 2. Has no values yet because we are going to calculate in this looping operation. So I is going to be row index, J is going to be column index, and both are integer variables. Nested loop. Let's do it for each row. We're going to add all for all columns. So I is going to be 0 to 2. J is going to be 0 to 1 only because there are 2 columns. So just Cij is equal to Aij plus Bij. So in this way, we're going to add all elements of A and B and keep the results in C. In this loop, we just print on the screen, row by row, from first row to the last row, and each row we printf for all columns. This is the first column, this is the second column. We only vary the I. So this are put on the screen. Three-D array also not tested. Let's say we have these matrices A and B, and we want to store these matrices in a single matrix named C. Of course, for plural is matrices, singular is going to be matrix. And of course, we want to print the second table. So with 3D array, what happens is basically you have to stack the matrices this way. Put this B behind A. So we're going to call the one at the front table 1, the one at the back table 2. Of course, for the one next is going to be table 3 and so on. Of course, in this case, we're going to have only 2 tables. It's going to be table 1. Behind it is B, table 2. So C is going to be, has 2 tables, and each table is going to have 1, 2, 3 rows, and 2 columns per table. So basically, the table index is going to be 0, the first one here, 1, the one behind it. Of course, each table, the row is going to be 0, 1, 2, and the column is going to be 0, 1. How to store these values in a 3D array? So this is the syntax. C is the integer 3D array. It has 2 tables, and each table there are 3 rows and 2 columns. So first table, first row, second row, third row. This is going to be the second table. In the second table, first row, second row, third row. Of course, you cannot display 3D array on the screen. The screen is only 2D. So here we want to print the second table. We want to print these elements of C, which we keep in the second table. So printf, of course, row by row, C. The second table, remember the index is going to be this. The first table is 0, the second table is 1. So the table is 1. We vary the rows, but for each row, we print the value in column 1 and column 2. And finally, how to pass arrays to a function. Again, this is not tested. The entire array can be passed to a function as an argument. The previous example, we want to calculate the average of 5 numbers using a function average. But the values here of x are stored in one-dimensional array. So we call the function average, pass the number of elements, of course, it's going to be 5. So this whole array we can pass to the function through the function the array name x. Pass to the function. Of course, inside the function, the argument is going to be here the array name with the square bracket empty, no values here. So what happens is this whole array is going to be passed to this function. It's like copying this and you copy and paste here. So this value is going to be available here. So in this loop, we can add from x0 to x4 to sum and then get the average. Return AV, return here to where we call the function. Basically, delete this, replace with AV. So average is AV, print AVG, we get the value of average. Of course, you run the program, this is what you get on the screen. So this is the end of C programming. In the next lectures, we're going to look at MATLAB programming. Of course, there is no free MATLAB compiler, so we're going to use a compiler which is 99.9% compatible with MATLAB, which is the Octave compiler. Thank you.